Good morning, Connie. This is Dr. Eric Rasmussen. We have an emergency unfolding in San Diego.
For 5 days in August 2006, more than 800 participants, observers, and local volunteers came together at Strong Angel 3, an international humanitarian response demonstration held in San Diego, California.
Strong Angel as a series originally developed because the U.S. military wanted to have a slightly better understanding of how we respond effectively when we arrive on site to a man-made or a natural disaster, where we find ourselves on the ground with organizations that know a great deal about disaster response, and we don't do it quite as frequently. And for that window of time when we're working together, how can we be effective?
The Strong Angel team chose the scenario of a lethal pandemic coupled with a cyber terrorist attack to provide an adverse context designed to stimulate learning, sharing, and experimentation.
These organizations traditionally have systems that are incompatible with one another, have very different roles within a disaster response mission, and we are trying to bring them all together in the same room to help them explore ways that they can work together better.
The whole goal is openness, so we can all contribute and share the common specification, and we encourage you to share the code that you guys have, and we'll do the same.
Groove had a significant role in Strong Angel 2. It's being used here to facilitate a great deal of the collaboration between different organizations participating. Groove natively works offline in disconnected environments, so we know that there's a match there. What we're doing now is connecting different systems to Groove using SSE.
We have developed the SSE spec and code samples on which we built a system to do bidirectional RSS.
Simple sharing extensions is a data format along with a synchronization algorithm that allows the information to be taken out of Groove and put into a format that almost anyone can consume, so the data can flow bidirectionally.
Not only can you subscribe to information that others are providing, you can change your information or their information on the fly and send it back into the center of this SSE cloud for access by the other systems.
We are trying to keep track of where Rob and Gabe and others who are out in the field collecting data, where they are.
We're taking pictures and we're feeding actionable intelligence back to the command center.
What they're doing is they're entering information into Groove. That information, whenever they have connectivity, is being sent over to my device.
We're going to upload the pictures that we took of this overturned car, and we're going to locate it on the map to our current location.
We have two systems running right now. You'll see on the left-hand side was the virtual Earth.
The idea is creating bridges between applications, bridges between devices, bridges between operating systems.
Spot, Simple Personal Object Technology, is a watch that will collect MSN-based data over FM radio networks. We are now integrating disaster response systems with the Spot technology so that we can push out alerts and notifications to first responders wearing these watches.
Right now I'm waiting for messages to come back from our command center to give us status on what's happening at Strong Angel Command.
Okay, the watch will beep when we get a message. By clicking the enter button, we can read the message. The first message says, medical teams please update location and communication status to the SA-3 Corps.
We are here to support the Strong Angel exercise with geospatial technology. It allows people to take dynamic information and geographically represent them on a map with what is happening where. Today we are taking the information that we've been able to collect for the last 3 or 4 days, bring it together, display it, and do analysis with it. And that's the power of geospatial capability. We've worked closely with Microsoft in a number of ways. We use the SQL database, which drives GIS. We're using Microsoft's Groove technology to collaborate with a number of people in a secure peer-to-peer environment. We're using Microsoft's Virtual Earth technology to be able to look at oblique images of areas to better understand what they look like. So it fuses a lot of information and creates actionable information for decision makers.
We are bringing people together who would not ordinarily have an opportunity for such a conversation, who have the opportunity, in fact the mandate, to talk with each other about problems they've all faced in common over the last decade.
The goal is ultimately to find ways to save lives by improving information flow across boundaries.